Orleans with Brady Gaster.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your team to move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that helps .NET teams be self-sufficient and able to deliver world-class results. And by the way, any companies needing fractional software leadership or a fractional chief architect, go ahead and give ClearMeasure a call. They help in-house software teams move faster and increase quality and improve production stability. And they've been a good sponsor of the show. If you have a comment or question for the show, send me an email at podcast@palermo.network. Also, my new online TV show has launched. It's in full swing. You can search for, quote, Programming with Palermo in any of the podcast directories. It's a video show, and you can also find it at www.palermo.network. We have a returning guest on the show today, Brady Gaster. He's a principal program manager on the Azure Developer Experience team at Microsoft, where he works on Orleans, SignalR, microservices, APIs, and integration with Azure service teams, and hopes to make it exciting for developers who work on .NET apps to party on in the cloud. Brady, welcome back to the show. How are you, sir?
I'm doing pretty good. How's it going? It's early out here in the Pacific Northwest this morning, and I was looking forward to talking to you. So,
awesome.
Good morning to you.
Yeah, it's been a couple of years. You were on an episode 102. We'll put a link to that in the show notes. We were last talking about SignalR. You were partying hard on SignalR a couple of years ago, and now you're on Orleans.
I'm on Orleans. I'm still on SignalR, but I've also adopted Orleans. I'll talk a little bit about that later. That was a fun conference. That was the last in-person conference we did.
Yeah.
Before everything shut down.
Before the year or two hiatus.
Yeah, exactly.
Yeah, it's exciting. Everything's back in swing, swing again. Well. For the listeners who maybe haven't heard your previous episode or haven't heard you speak before we kind of jump into it, I mean, you've done so many things, but what are the high points on some of the exciting things that you've done and loved that have kind of led you up to what you're working on today?
Being on all Palermo shows. It's always been fun. Yeah. One of the things that I've kind of committed to when I got to Microsoft was, I don't know if I talked about this before. The last time we chatted, I was a marketer. I was in the marketing team. Before that, I was in the content team. I was one of the people that helped build Docs Microsoft Com in the beginning. Mm-hmm. Before that, I was on the same team that I'm on now, Hunter's team. Or not Hunter's team, but the .NET team. Hunter's over Azure now, so he's moved over. Mm-hmm. But essentially, I wanted to try to figure out all the different ways that Microsoft interfaces with developers. So when I first came to Microsoft, I was an evangelist. I was a cheerleader. That's how I got into SignalR. I was doing great demos with SignalR and learning how to use it, and for the love of God, how to not use it. And then transition to engineering, and then docs, and then marketing, and then back to engineering, because that's kind of where I belong. But the whole time I've been working closely with ASP.NET. You and I were talking about ASP.NET before I went to Microsoft. I've been doing it forever, but it's been fun to kind of do the journey and kind of figure out like I like being in engineering. I figure that's like the place that I like making the biggest impact. But moving around a lot really gave me a lot of insight into like all the different ways that we can benefit developers and all the different opportunities we have to make things better. I think the only thing I haven't done yet is work for a service team. Mm-hmm. And there's that whole on-call thing. Those people are angels on the earth. So I appreciate everything that they do. I just don't know if I'm capable of doing that.
Well, you mentioned Docs, especially at a company whose chief product is software. Mm-hmm. It struck me of how much the Docs writing team essentially programs all day, seemingly, because everything is a sample.
Yeah, everything's a sample. I'll give you a great example of that. One of the people that I met in the back of the Scott's talk at one of the MVP summits was a gentleman you may have talked to previously, David Pine. Mm-hmm. He's one of our content people, and just thinking about David as just a content person does not do the guy justice. Yeah. Same thing for Cam and all the other guys on the team. They really tinker a lot, and they really come up with good ideas. And the other day, we shipped .NET 7, and on top of that, we shipped to Orleans 7. And David Pine had worked on some of the content and some of the samples on docs for Orleans.
Mm-hmm.
So he pings us and he's like, hey, I have some feedback about upgrading from 3X to 7. And I was like, I'm sure you do, sir. It's like, good thing you've got admin rights on that doc. So,
nice.
He's like, starting to add to that, what's new in Orleans or migration to Orleans 7. He's starting to contribute to that. David's also the person that anytime I want to ship any code, like a demo code or sample code or do something on stage, I always run it by him first. For what it's worth, I run it by Fowler too to make sure I haven't done anything bad. But I always run it by David, and it always comes back prettier. Like David knows how to take code and just like make it poetry. Just like he's really good at it. He's really good at like cleaning up code and making not only the interface look better, but like when you have to walk through somebody's code later, it's really great when David Pine's been the one to tailor it, because you can kind of figure out what's going on a lot better than you can when it's just me.
Gotcha.
So
yeah, for sure.
Yeah, it tended to happen when I was my code quality guy. But you're exactly right. The people over in Docs, they hack all the time. Like Rick Anderson in ASP.NET, he hacks all the time. He's got tons of feedback on APIs for us and stuff. But they really make the product better by banging on it. So
yeah, in order to explain something, you have to know how it actually works.
Exactly. I think when I first got to Docs, there were a lot of writers who were writers first and geeks second. And over the first year or so of the new Docs organization, that kind of changed. There was a lot of really deeply technical people there now. So it's really fun to see. There were then too, but it's good to see them all diving in.
Sure. Well, let's talk about Orleans. But before we can jump into it, there's people out there listening that are thinking, what the heck is it? So why don't we start there?
Yeah, that's cool.
People getting on the train. What is Orleans?
That makes sense. I should give you a couple of the slides that I'm looking at right now. And I'll give you a couple of links to other sessions that we've done on Orleans.
Yeah. Like
the stuff that we did for .NET Conf. I'd highly encourage people to take a look at as we talk about some of the new features in 7. So let's talk about Orleans from the context of, let's put on our ASP.NET developer hat for a minute. Let's think about all the different things that you have to do for ASP.NET. So in the ASP.NET model, think about the different primitives that you've got. You've got like controllers, and thank goodness with 6 and beyond, you've got minimal endpoints. So you can just do a map get or a map post. You've also got, SignalR hubs. Those are definitely a component of ASP.NET. And then like worker services, when you've got like an I worker service or a background service that you just happen to put inside of your basket and it runs in the background. What do all those things have in common? Where do they run? They run on the server, right? So this is very important to think about. They run on the server, as in one server.
Yeah.
But what do you do when you want to like scale an app out? I know at Clear Measure, y'all build out a bunch of, big apps, horizontally scalable apps and whatnot. We've all had to slide the slider in app service at one point or another. But you don't really think about all the complexity of what's going on under the covers of that until you do it in like a containerized environment or in an environment that doesn't have sticky sessions. That's where Orleans comes in. Think about the nature of, doing a SignalR hub, for instance, in a web farm environment. The hub lives on the server. So if you send a chat message, I'm talking about chat in SignalR, even though that's against my religion. If you send a chat message from server A and you've got people on server B, people on server B are not going to see the message unless you drop in what's called a SignalR backplane. Well, that's also true for things like session state, anti-forgery tokens, cookie decryption, blah, 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 blah. And it's also true for things like distributed cache. Distributed cache is a really great example of where Orleans can benefit somebody, because essentially the primitive in Orleans is this thing called a grain. And a grain essentially represents not only the nouns, like, a person object, an account object, but it represents the behavior as well. So, you might have something like an account grain, and the account grain might have withdrawal and deposit, for instance. And, those are the virtual actors. When you talk about Orleans in the context of the actor model, the grains in Orleans tend to be synonymous with actors in the actor model. But essentially what those grains do is they forge a layer underneath all those servers, and they essentially cluster all those servers together so that you could make a call to say, from server 1, you could make a call to account A and account A might be on server 23. You don't need to know to go to server 23 and to make the call to that object and then to come back. You just go grain factory. I need account number 23, and it gives you account number 23 from server 34, and you make a change to it and it goes back. So that's the benefit of Orleans, is that it legitimately obfuscates the hardware layer and the farm out layer. So you don't have to worry about it. You just make calls to the grain factory. The grain factory gives you the grain. You make changes to the grain, and the grain saves everything in your database. It also makes the concept of like doing ACID transactions pretty much transparent. You don't have to do the concept of begin transaction and end transaction and all that. Orleans handles that for you. So rather than you having to like come up with a first layer cache and a second layer cache and then your database, you basically make a call to the grains, and the grains are intelligent enough to know how to save that data in memory and then persist that data to, longer persistence when need be. So essentially it obfuscates a lot of the complexity of like creating an API and then creating a database layer and then creating a this and creating a that, and then figuring out, oh crap, we have to scale this out now. With Orleans, it just scales. And we were talking the other day about some of like the traditional cloud native concepts that other products like Dapper do a really great job at. Things like service discovery, secrets, and all that good stuff. Those are like those microservice considerations that you've always got to think about no matter what you're doing.
Right.
As mentioned, it was really kind of funny. I used the phrase Orleans and service discovery in the same sentence the other day, and I couldn't help it. I started laughing. And I was like, it's just like, you don't think about it. You just say, I want account number 23, and it just gives you account 23. There's no concept of having to go, which server is it on, and make a call to that server. So it obfuscates a lot of that complexity.
So that seems to assume that in that environment, there's some type of data sharding across, where it's not a central data store that all of the services are going to, but each of the service has a segment of the data.
That's a great thought. Think about each one of those silos. That's what we call it. Like if you have a grain, and it's really funny. Like if you think about the nomenclature, like somebody asked me, what's Orleans good for? I would say a web farm. And then you start talking about it, and you talk about grains, and you talk about silos. A silo is the server where you host the grains. And then people go, what do you call the big thing? And it's like, you want to say farm? It's not a farm. It's a cluster. It's like we messed up that one term.
Okay.
Because like you put an Orleans cluster inside of an AKS cluster, or inside of an Azure Container Apps environment, or even inside of a virtual network and app services, you know what I mean, or on your VM. Essentially what's happening is each one of those silos, rather, that host the grains, they have this concept when you wire it up. Just like everything else in ASP.NET, we've got like, middleware and services that you wire up. I think the call is actually use Orleans. And then when you call use Orleans, there's a silo builder that you pass into the Lambda, and then you can configure the silo. When you're configuring your silo, you can set up grain storage, and grain storage can be any ADO database, SQL Server, and anything else supported by ADO. It can also be Cosmos DB. To quote Mark Brown, what better database to use for a distributed application than a distributed database? Because he's the Cosmos DB PM. The kind of the canonical one for folks that are doing Azure is obviously Azure storage, using storage to store not only your grain data, but also your cluster data. So all the different machines, like, this machine's on IP address foo, that machine's on IP address bar, et cetera, et cetera. So essentially when an Orleans silo spins up, there's a couple different ways that it can store that data about the cluster. One of them, default, is in memory. If it's in memory, guess what? You're only going to be on one server. You know what I mean? Yeah, so you got to put something underneath it. The thing you would put underneath it would be, one of those data sources, one of those persistent sources. Like I always use Azure Storage or Cosmos DB. You can also bifurcate. So let's say you've got a scenario where you want to store your account model data in Cosmos DB, but you want to store your customer data in an ADO database. You can do that. You can mix and match. So that's good. And then you can also pick, Orleans has reminders. So you can basically set, like, rather than writing a background task in .NET, you can actually write like a grain, and your grain will have a reminder or a timer on it, and it'll just keep firing. I'm actually going to write some code today where I change an application around that has an I-hosted service in it. I'm going to take the I-hosted service out and put a timer in the grain, so there's no service. It's just all the grain. Like Orleans will do all the work. But it's good for stuff like that as well. You can basically set up these recurring tasks So grains can kind of clean up after themselves, or they can massage the data however you need, or they can move the data from point A to point B, and so forth and so on. So you do have all that capability. But that kind of summarizes what Orleans is. If I had to put it in like three or four sentences, it would be, Orleans basically adds distributed processing to the ASP.NET Developers Toolchain, or the .NET Developers Toolchain, and does so in a way that it doesn't feel like an entirely new API they have to learn, like an entirely new service layer or whatever. Like we actually talked to a bunch of customers when we were figuring out what we wanted to do with Orleans next. And a lot of them who had been using Orleans for an extensive period of time said, Orleans kind of made me do .NET right. Like they made me think about async await the right way, made me think about inheritance the right way, et cetera, et cetera. Orleans is very .NET centric. It's not like other frameworks where, they support Polyglot, like are very .NET centric.
Yeah, nice. Now, so is Orleans something more like a NuGet package that you run in your application, or does it have any similarities with Dapper where you run it in your environment?
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
That's a good question. Right now, the entirety of Orleans is more of a programming model than it is a service layer like Dapper. With Dapper, you have that thing the sidecar you drop in. With Orleans, you just have a series of NuGet packages that you reference. If you're building a silo, if you're building the server side, it's literally, we just made it a lot simpler. There used to be a series of NuGets you had to install for everything. Now it's gotten a lot simpler. With Orleans 7, if you're building, say, a grain package, a grain assembly or a grain interface assembly, you would reference Microsoft.orleans.sdk. That's it. If you want to host it, if you want to host grains inside of a silo, instead of the SDK, you would change that to server. So it's Orleans. It's Microsoft.orleans.server. And then if you're building a client that talks to a backend silo, and when you say a client in Orleans, you're not talking about a phone or something like that. You're talking about a client that's actually on the same network. So in Orleans, a client might be your web API. And your web API connects to the cluster as a client and makes calls to it. But your web API can also be a cluster, a silo in the cluster that's just connected to the cluster. The latter is definitely more performant. That's kind of what we recommend folks do.
Got it.
So speaking of performance, when you think about the stuff that we were doing, there's a couple baselines and benchmarks that have been published. When we saw the recent baseline that came out, it compared Orleans to Akka, Akka.NET, and Proto. Proto Actor, I think was another one, and then Dapper. Like Dapper is definitely more of a service thing, but when you looked at the performance, the Akka, Orleans, and Proto are probably more similar in nature than Dapper's. Dapper is like a lot of other microservice benefits to it. You know what I mean? The first three are definitely more firm actors. There are Dapper actors, but there's a lot more to Dapper than just an actor map. But when you look at the performance that we did a bunch of changes in Orleans 7 that we've wanted to do for a couple of versions that we knew were going to be breaking changes. We went ahead and decided to make that investment because Orleans and .NET are moving closer and closer together. You'll see that continue through .NET 8 as well. But we've got some areas of performance we've actually increased. I'm looking here like 4x, 4 to 5x.
Wow.
On an Intel Xeon E5. With Orleans 3, we were getting around 200,000 messages per second. Now with Orleans 7 on that same machine, we're around 760.
Wow.
Yeah. Wow. And then if you look at like an Intel Core i9 desktop at 2.3 gigahertz, and all this is in the presentation we just did at .NET-Conf, the Orleans 3X was around 700,000 messages per second. With Orleans 7, it's at 3 million.
Yeah, it's big.
So, yeah, it's big improvement. And then on an AMD Ryzen, which is our test machine, our lab machine, with 3.6, we were getting around 1.7 million messages per second. Now we're getting close to 5 million.
Now,
So
in the lab, you have those machines, but are you using Azure storage to interact with, or what are those configurations?
This is a baseline that doesn't use any backend storage. This is just in memory. I have deployed a completely untuned set of services to Azure Container Apps on the smallest size container I could get. I think it was 0.25 and 5. I deployed that app. Like I said, it was totally not optimized, and my code does not perform ever as a general rule. And we had one client and one silo, and I think we were getting north of 6,000 RPS. So you can get pretty high. I mean, that's low in contrast to our test machine, but the test machine's a bear. It's huge.
Oh, for sure.
But you'll see a lot more performance. And if you compare it to some of the things that are just built into ASP.NET 7, now that we've got so much more performance, you probably saw the Stephen Tome. .NET 7's performance is Lightspeed faster set. But you couple all that together with the speed of Orleans, it's pretty good. And we also support open telemetry now. So you've got the capability of being able to, trace messages that go from one end of your system all the way to the other end of your system through multiple silos and multiple clients. And you can trace it across machines now because you support open telemetry. So,
well, talk about that for a second. Open telemetry, I think it's new for a lot of people, and
it is.
App Insights supports it, but it's its own thing, and you guys have implemented it. What is the thinking? How do you think about open telemetry and why you wanted to add it?
The way you think about it, I'm glad you asked, because I had that slide pulled up here. Ruben really does a great job of summarizing it. If you think about the 3 pillars of observability, and we came up with that right before we were doing our presentation, it's really just logging, distributed tracing, which is really where OpenTelemetry shines, and then metrics. So really the idea behind OpenTelemetry is, think about it from a non-Microsoft perspective, is it's a group of folks who got together almost like SOAP board, and they say, this is how we want to support logging, distributed tracing, and metrics. And they came to a set of agreements through a set of debates, obviously, and came up with how to represent, general logging, general tracing, and general metrics, and how to basically snap things into it. So essentially, if you just have a standard .NET app, and you wanted to use the global tool called .NET Counters, you could aim .NET Counters at a running app, and it'll just spit out all the normal .NET counters to you. But you can actually add counters to it. You can say -- counters, and you can add Microsoft.web or Microsoft.Orleans, and it will show you an additional set of counters, an additional set of metrics specific to that piece of the runtime. Now, with OpenTelemetry, you basically just have a format that you're dumping it to and sending it to a repository somewhere. And our demo that we did for at .NET Conf for Orleans 7, Ruben showed how to use, I've actually got his chart right here. He actually shows how to use this GPS tracker app that we have that spills data using OpenTelemetry to Zipkin and Jaeger. And essentially, that's actually pumping out trace monitoring. So you open up Zipkin or you open up Jaeger, which are just 2 things you would install in your Kubernetes cluster or your ACA cluster or on your local machine using Docker. You fire those up, you get their ingress endpoints, which are pretty standard, and you wire up your .NET code and you say, I want you to pump out to this URL. It will start to pump that trace data directly, or not trace, but the trace monitoring directly to Zipkin and Jaeger, and you can open those up in your UI and watch them pump. At the same time, you could pick Azure Monitoring or Application Insights as a destination and have it pump over there. So you could monitor it locally using Jaeger or Zipkin, or you could monitor it in the cloud using Application Insights. At the same time, if you wanted to move it to some other host, if that host supports OpenTelemetry, essentially you would just change the URL that you're pumping to and you're off and running. So the nice thing about OpenTelemetry is that it gives you a ubiquitous format to kind of see your logging, your tracing, and your metrics, and either on a single machine or nobody does that in a cloud native environment across multiple machines. So it really helps you kind of figure out where things are falling down, where signals are blowing up, et cetera, et cetera.
Well, that's huge, because I guess when I started, everything we ran in production, we could run locally. Well, now with Azure, I can't run Application Insights locally.
No, you can't.
And various other things. So having something that kind of is the same abstraction, really useful.
It's really great. The other thing you can use, like I mentioned, .NET counters. You can also you can run as a sidecar in like Azure Container Apps or AKS Kubernetes. You could run .NET Monitor as essentially a sidecar, and you can give it the process ID of the app you want it to watch. So if you're running a .NET app in a container, you only have one process running, unless you're doing something else odd. But you can basically say .NET counters, I want you to watch this shared volume on the computer that's hosting the container image. And you tell your app, I want you to pump your data over here. And .NET Monitor will just collect it. And you can actually have .NET Monitor dump your data over to Azure Storage or the hard drive, which you can do in a container. But with the open telemetry stuff that we've got in .NET 7, you can literally just wire it up to pump directly to Prometheus and Grafana as well. So if you're in a shop that uses one of those reporting tools instead of application insights, you have that capability as well. I think in the .NET Conf keynote, David Fowler did an example of showing a non-Orleans app, just a typical .NET 7 app, pumping data into Azure Monitor using OpenTelemetry. So if you want to see that, definitely check out the .NET Conf keynote, kind of near the end when David shows up. So
yeah. Well, I'm thinking about the traceability side of OpenTelemetry and how many times we do some type of transaction or a user clicks some button and the code is going to various servers here and there. And when you look at logs, well, you're just looking at one particular process, but what you really want is, no. I want to see everything that happened after that button click. I don't care what process it went to. That's a big problem.
It is. In the past, when we set up like deliberately architecture kind of contrived solutions where we're running either an Orleans app or a Dapper app, or in the case of like that wild demo we did for Hanselman, the rock, paper, scissors, lizard spot demo where we had multiple languages. In the case of one of those, OpenTelemetry is huge because what you can do is, like, if you think about running in Azure Container Apps, you're going to have your environment. You're going to put a bunch of apps in that environment. Every Azure Container Apps environment has a log analytics backend associated with it. And all the logging just goes there just by default. So you could have 20 containers or 2,000 containers, doesn't matter. All of them are going to log to the same place. And it's fun to go and look at those logs because it's a time series log. So you can look at it and you can see, the orders controller and the orders container, and then the account management container, and then the orders container, then the orders container, then the inventory container. So you can see the log happening as it's bouncing between all the machines. And then if you open that up in Application Insights, was it the app map, the application map? You can visually see everything and you can see all the signals going around. That's a great little tool if you haven't used it. Is just go into the app map and Application Insights. You can see everything flying around.
Yeah. Well, as we get to the end of our time here, I'm going to want to close off on Orleans, and let me ask you a question on a scenario. If I'm thinking about this properly, you've mentioned having multiple instances of a particular application service that has different segments of data in various places. Does it also apply? This is where you tell me if I'm thinking about it right or wrong. Does it also apply to IoT, where instead of data that's stored, you have data that's gathered from the physical environment, but you have just tons of the same version of the app running in all kinds of different places physically?
Yeah, that is a canonical use case for Orleans. And in fact, one of the internal customers that we talk about frequently is Azure IoT Digital Twins. If you think about what that product is, it's this Azure service where we've got a thing in memory that represents the physical thing in the world, like a device in the world. In the Azure IoT Digital Twin service, every single device, this is great, every single device that connects to the Azure IoT Digital Twin service is represented in that service as an Orleans grain. So like that's a perfect example where you've got like an IoT device is represented in an application by a grain object. That you're going to have thousands of grains. You're probably going to want to have a couple dozen servers. So at any given point, you never know where that next request is going to come in. And in fact, the training material that we're writing for our service team, who's going to support Orleans in the future, that's one of the things that's part of the training material is a very fast application that, you've essentially got, 20 or 30 apps running on your machine that are feeding a silo data. And and they have to learn how to wire that all up.
Mm-hmm.
So, yeah.
And we didn't do that at the beginning, but when you say grain, you just mean a C# class instantiated as an object that implements a certain interface.
Correct.
But it's your code that's sitting out there in memory running, doing certain things.
That's correct. It's that's why I liken it to a SignalR hub and an MVC controller. It's just another type of object.
Mm-hmm.
A grain. When if you hear somebody talking about ASP.NET and you hear them say hub, you know what they're talking about. Now,
it's a class.
If you hear somebody say a grain, you know what they're talking about. They're talking about a specialized class in ASP.NET that implements an interface. So yeah.
Awesome. Well, hey Brady, thanks so much for coming back on the Azure DevOps Podcast and giving us an update on Orleans. This is fascinating.
No problem. I'll give you some links so people can go try some stuff out. So,
yeah. We'll include that all in the show notes for sure. All right. Thanks so much.
Thanks a lot.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.